All right, in this question, we know that the polynomial of degree 8 has the following zeros, right? 2, 2 minus 4i, and minus I. So the question is, we want to determine other zeros, and we want to figure out what is the maximum number of real zeros that can have. All right, and let me stress, is asking about the real zeros, not all the zeros. Now, for the first part, we're going to use the first formula with the conjugate zero theorem. So the conjugate zero theorem is stating that if z is a zero of p of x, right, then the conjugate, which is called z bar, is as well a zero of p. All right, so let me elaborate this. So if z equals to a plus bi is a zero, then z bar, which is the conjugate, it will be a minus bi as well as a zero. So for our case, we have the first one is 2 minus 4i. So the conjugate of 2 minus 4i, it will be 2 plus 4i. And the second one, which is the minus I, is nothing other than 0, all right, 0 minus I. All right, so if I do the conjugate, this would be 0, switch the minus into plus, and it's going to be I. So here you go, we got it. So this is two other zeros that are possible, so I can add them up, 2 plus 4i and I over here. Okay, now the second formula is telling you that any polynomial, all right, with degree n greater than 1, you're gonna have, counting the multiplicities and stuff, you're gonna have exactly n zeros, counting the complex zeros and the real zeros with their multiplicity, corresponding multiplicity, right? So now, what has to do this with this? Because we know here is a degree 8, so the total number of has exactly here 8 zeros. So from these 8 zeros, we have 1, 2, 3, 4 of them are complex zeros. So we're going to take away 4 complex zeros. And then if we do the subtraction, the remaining one is going to be a maximum of that, a maximum of a real zero. All right, it can have up to 4 real zeros. This is not sure yet. We could have not 4 exactly, but we could have 3 or 2, or we know at least we have 1, right? So we can have 1 as well. All right, so most likely going to be maximum of 4, and that's basically the answer that you are looking for. All right.